Okay, guys, so 811, we are approximating logs and using change of base theorem. So like I said, abbreviate that. Abbreviation for theorem is THM. Just a little factoid for you, okay? So basically what we're going to be doing is I'm going to be giving you logs that you cannot get the same bases. And so we're just going to approximate what the exponent has to be, and then we're also going to introduce what is called the change of base theorem, and I'll explain to you what that is and kind of why we use it, okay? So, first two are going to start with examples. Please do not write every single thing because then we're going to be writing forever. So, part A, I want you to write down log base 2 of 10. Okay? So we're going to start with log base 2 of 10. How would I rewrite that as an exponent? Set it equal to x, and we would get 2 to the x equals 10. So I want you to write that also, okay? So log base 2 of 10 is the same as 2 to the x equals 10. And then normally we would try and get same bases and solve. Can you rewrite 10 as a base of 2? No, we can't, right? So normally we would just stop here. Now I'm going to show you how to approximate the value of x, so what exponent needs to be plugged in, just to approximate without having to actually find it. So, does everybody know what is 2 to the third power? 8. So write that down. 2 to the third equals 8. So to approximate, we know that 2 to the third equals 8, which is less than 10, right? What about 2 to the fourth? What does 2 to the fourth come out to? 16, which is greater than 10. So we know that 2 to the x has to be somewhere in between 2 to the third and 2 to the fourth, correct? Because the answer comes out in between 8 and 16. So we would say that the exponent x will be between the consecutive integers 3 and 4. So we're just approximating what exponent I have to plug in to get an answer of 10. Because 2 to the third is 8 and 2 to the fourth is 16 and 10 falls between those two, I know that my exponent also has to fall between the exponents 3 and 4. This was kind of like all the way back in pre-algebra, which for some of you was 4 years ago. Remember how I would give you like the square root of 20, but it's not a perfect square. So to approximate, you would find the perfect square right above 20 and the perfect square right below, and then you knew that the answer had to be somewhere in between there. Same idea. So we're just approximating, okay? Let's do one together. So part B, I want to know if I give you log base 3 of 25, between what two consecutive integers does x lie? So what we can rewrite this as 3 to the x equals 25, and I want to know what two integers does x fall between. Here's how I want you guys to show you. We need to figure out the exponent that is directly below 25, and then the next exponent of 3 that's directly above 25. So let's start with 3 to the second. What's 3 to the second, guys? 9, which is definitely below 25, right? And then the next one is 3 to the third, which is 27. So 25 falls between 9 and 27. So my exponent has to be between what? 2 and 3. Because 25 is closer to 27, I know that my exponent will probably be closer to 3 than closer to 2. So if I had to guess, it would probably be like 2.8 or 2.9, but I don't care about that. All I want to know is what does it fall between. So either between 2 and 3, 3 and 4, that kind of thing. Okay? That's really all you'll have to do. So try 1 and 2 on your own. So I'm giving you log base 7 of 9 and log base 3 of 200. So try those right now. Okay, so first of all, how would I rewrite log base 7 of 9? 7 to the x equals 9, okay? And then I need to write off to the side. 7 to the what is going to give me this one smaller than 9? 7 to the first is 7, and so that means 7 to the second is 49. 9 definitely falls between 7 and 49, right? So what two consecutive integers does x fall between? 1 and 2. So your exponent, okay? Number 2, log base 3 of 200 can be rewritten as 3 to the x equals 200. So what two consecutive integers does x fall between there? 4 and 5. Because 3 to the 4th is 81, and 3 to the 5th is 243. Okay? So because 200 is between 81 and 243, our exponent has to be between 4 and 5. Okay? Make sense? Okay. So let's do what we call change of base formula then. Change of base formula comes about from when people would try to do logarithms, but I want you guys to notice on our calculator. So if you can do logarithms on a calculator, and they're up here. But do you guys notice what two bases are the only ones that I have? I have a log and an ln. So what are the two bases that my calculator can do? 10 and e, right? So if I gave you like log base 3 of 5, could you do that on the calculator? No. So change of base formula gives us a way to rewrite a logarithm with a numerical base that's not 10 or e, so that we could change the base, plug it into the calculator, and get what it actually exactly comes out to. Okay? I'm not actually going to have you guys plug them into the calculator, so I'm going to give you change of base formula and we're going to practice with it, but I'm going to give you whatever base I want, so it's not always going to be 10 or e, so we can still do it with other bases. It's just that the most practical one is 10 and e, but we're going to do it with all different kinds of bases to get used to it. So here is your change of base formula. I want you to write it nice and big, just the stuff that's in the box. Change of base formula. Here it is. A, B, and C are all going to be numbers. So if I give you log base C of A, so some numerical base of some number, you can rewrite it as a fraction. So we can rewrite it as log of a base B. B can be any base that I want as long as it's positive and not equal to 1. Okay, so B can be any base that I want. So we change the base to whatever you want, or whatever I tell you, of A, and then we put it all over log of the same base of C, your original. Okay, so like I said, we typically do this because calculators only work in base 10 or base E. So the reason why this was kind of discovered is so that we could plug it into a calculator using bases 10 and E. Like I said, I'm going to let you do that with base 10 and E, but I'm also going to give you different bases just so that you can practice, okay? Okay, so we're going to do two problems using change of base formula. So the first one, I want you to find log base 5 of 7, and I want you to use change of base formula to change to a base of 2. So just like I said, normally the purpose of this is to change it to bases 10 or E to use in a calculator, but just to practice, because I'm not going to have you plug them into a calculator, I want you to do it in base 2. So here's how we would do it. Base formula means you take the whole thing and turn it into a fraction. So the first thing I'm going to do is draw my fraction bar. And on top, I put log of my new base, so base 2. And on top is the number that you were taking the log of. So on top is going to be log base 2 of 7. Okay. On bottom is going to be log base 2, because the bases have to be the same, of your original base, which in this case was 5. And that's your answer. Okay. What I want you guys to make sure that you are aware of. Log is a notation. It's telling you that this exponent is written in a certain notation. Log is not something that can be reduced or simplified or divided or distributed. So you cannot divide log base 2 and log base 2 and end up with a 5 over 7. Does that make sense? It's a notation. So you have to keep it as log over log. Okay? So that's really all you have to do. So what I want you guys to do is do number 4 for me. change log base 2 of 3 to a base of 10. So you're going to do the exact same thing that we just did, but this time you're going to do it in a base of 10. Okay, guys, so because I'm changing to a base of 10, that's going to be log by itself. If you wrote log base 10, that's okay too. What goes on top? 3. So it's log of 3 over log of what? 2. And that's your answer. So like I said, the reason that we do this is because my calculator, let's see if I can fit both of them on here. My calculator only works in bases 10 and E. So, so if I can use my calculator to find log of 3 and then find log of 2, I can plug them in. So if I plug in log of 3, that gives me 4.77. So if I wanted you to do all of this, log of 3 is 0.477 over log of 2 is 0.301. So log base 10 of 3 comes out to 0.477, and log base 10 of 2 comes out to 0.301. So 0.477 divided by 0.301 comes out to 1.585. Okay? So log base 2 of 3 actually is 1.585. Okay, but my calculator can't do that, so we had to use change of base formula in order to be able to plug those in. Does that make sense? All I want you to do is rewrite it using change of base. I'm not going to have you actually do this, okay? But this is kind of like those ones that we just did where you had to approximate. So if we were to approximate, we know that the exponent should be between 1 and 2, and if we actually calculate it on the calculator, it comes out to about 1.6. So it is between 1 and 2, okay? We can also use change of base formula in reverse. So I do want you to write this down in the box. The idea here is if you see a log base b of a number and it's in a fraction with a log base b of another number on bottom, that automatically tells you that it's a change of base because you have a log over a log. So you want, what I'm going to have you guys do is then take it from change of base and convert it back to one single log, okay? So you can get rid of the changed bases, and then we're really only concerned about the original number and the original base. So we're going to do 3 like that, and then we're almost done. So first one I'm going to do with you guys, and then I'm going to have you guys do the last 2 on your own. So the first one is log base 5 of 8 over log base 5 of 7, okay? So typically before, we've only seen fractions in a single log, and then the fraction is inside of the log. Because I have a log over a log, that tells me that whoever did this problem used change of base formula to get it written like this. So we're going to ignore the new base of 5, and we're going to write this whole thing as a single log. What is the original base of the original log? 7. So this can be rewritten as log base 7 of 8. So all I want to do is write it as the original log. Okay, so do number 6 for me really quick. Okay, guys, so number 6, I see log base 2 of 6 over log base 2 of 10. So because I have log base 2 over log base 2, that tells me that they used change of base formula. So to write this as one single log, what was my original base? 10. So do I have to write it? No. So it's going to be log base 10 of what? 6. So we're just going to do log of 6. If you want to write log base 10, that works too. But it should have come out to just log of 6. So let's look at number 7 really quick, and then we're almost done. Natural log of 4 over natural log of 3. I guarantee that somebody on their test is going to cross out the natural logs and give me their answer as 4 over 3. Okay, remember, log is a notation. It is not something that you can reduce or something that you can distribute. It's just saying that we're writing this in log form. What helps me is to first rewrite the natural log as a log base e. So rewrite this problem as log base e of 4 over log base e of 3. Okay? So that helps me also see that we have a base of e here. So if I were to rewrite this as a log, what would my original base have been? 3. So am I going to write ln base 3 or am I going to write log base 3? Log base 3. Of what? 4. Okay, so that's the only reason why I want you guys to rewrite it as log base e, is so that you make sure that you don't put ln base 3 because that doesn't exist. Okay, it's log base e, and then we put it all back in log form. Okay, so that's change of base formula. The last thing I want you guys to look to see, oh, we're going to express some things as a single log. Okay, so let's do number 8 together, and I'll have you guys do 9 and 10 on your own. So these problems, I'm going to have you write it as a single log, and then we're actually going to solve them, okay? So number 8, log base 8 of 81 over log base 8 of 3. Let's rewrite this as a single log first. That's going to be log base 3 of 81 because it was a change of base formula. We set the whole thing equal to x, and we get 3 to the x equals 81. And 81 is 3 to the what, guys? 4. So if we drop our bases, we get x equals 4. Okay? Do that for 9 and 10 for me, really quick. All right, guys, number 9, how would you rewrite log base 5 of 2 over log base 5 of 8? Log base 8 of 2. So to solve, we set the whole thing equal to x. So that's going to be 8 to the x equals 2. What base do I need to get both of these in? 2. 8 is 2 to the what? Third. So this is going to be 2 to the 3x equals 2 to the first. Drop your bases. So 3x equals 1, and divide both sides by 3. So we get x equals 1/3. Okay, so now I'm having you use your change of base formula and then using all our different solving methods to actually solve. Number 10, not the last one. If it's a natural log, that's actually log base what? Log base e. So this is log base e of 32 over log base e of 2. So the original log for that one would be log base 2 of 32. Set it equal to x. So 2 to the x equals 32. 32 is 2 to the 5th. So when I drop my bases, I get x equals 5. Okay. Okay, so the last thing I want you to do, I want you to solve the following problems for x. So that's our instructions. We're going to have to introduce log, and I want you to leave your answer in log form. Okay, so make sure that you understand for these, we're going to leave our answer in the log form. Okay. So the first one, 5 to the power of x equals 30. Okay, my initial thought is to try and get both of these as a base of 5, but can I rewrite 30 as a base of 5? So the only thing we can do is to rewrite this as a log. So this is going to be log base what? 5 of 30 equals x. Now, my instructions say solve for x, which means we want x equals. Do we have x equals? So you're done. Because we solve for x, we have x equals log base 5 of 30. That's all I wanted you to do. Okay? So let's try number 12. 8 to the power of 2x equals 74. Can I rewrite 74 as a base of 8? No, because 8 squared is 64, and 8 to the third is 353, bigger than 74. But we can also rewrite 8 as a base of 2. So can I rewrite 74 as a base of 2? 2 to the 5th is 32, and 2 to the 6th would be 64, and 2 to the 7th would be 64 times 2, so 128. So can I rewrite 74 as a base of 2? No. So let's put this back in log form. So that's going to be log base 8 of 74 equals 2x. Do I have x equals or x by itself yet? No. So what else could you do? What would you have to do to get x by itself? Yeah. So let's divide both sides by 2. Remember, you're dividing the whole log by 2. Okay? Now, I don't really like the way this looks, and the reason being is because a lot of times students will start trying to reduce the 8 and the 2 or the 74 and the 2, but those are both part of the log. 8 is the base of the log, and 74 is actually the answer of the log. So you can't reduce these with 2 because 2 is dividing whatever answer you get from the log. So I would suggest that we rewrite this as a fraction. Dividing by 2 is the same as multiplying by what? 1/2. So I would rewrite this as half log base 8 of 74, because that tells us that whatever we get for log base 8 of 74, then you take half of it. Okay, so I would prefer it to be rewritten as 1/2 of the whole thing. And then you're taking the log. But we have x equals, so you can leave it like that. Okay? And then last one, and we're done. E to the power of x equals 43. Like I said on the other problems, my initial thought is to try and get them as the same base. But have we ever changed a number to a base of e? I don't even know if you, really could, because e goes on forever and ever. So let's rewrite this as a log. If I have, my log is going to be log base what, guys? E of 43 equals x. So do I have the whole thing equal to x? Yeah. The only thing to do is we don't usually write log base e. How do we actually write that? Natural log. So it's going to be x equals natural log of 43. So we got x equals or x by itself. We just leave it in log form. Okay?